And so here are the notes for section 6.3, the definite integrals and antiderivatives. So down here to start, we've got the properties of definite integrals. So the zero property just states that if your bounds are the same, your value comes out to be zero. If you think about that visually, when this happens, the left edge and the right edge of the rectangle sit on top of each other, which means there is no length or width. One of them is zero, so the area of the rectangle can't exist. Additivity, so you go from a to b of f of x, and you go from b to c of f of x. That's the same thing as just going from a to c. So essentially, rectangle 1, rectangle 2, but rectangle 2 starts where rectangle 1 ends. So here's rectangle 1, and then rectangle 2 just picks up. Well, you might as well just do the whole area all at once. So a to b, b to c, just combine them all at once. Order of integration, this lets you reverse your bounds. So you go from b to a. If you drop a negative out front, you can go from a to b. So essentially it's changing the direction you're reading the graph, and you do that by adding a negative. If you integrate right to left, you get negatives, left to right are positives. Constant multiples let you factor things out, where k could be some number, or you can even just do a negative sign. Essentially this one down here is the case where k is -1. Sum and difference, this pretty much, you don't normally see this one get used a whole lot. Typically, this rule is used that you can integrate terms separately, although I won't personally write them broken down into multiple integrals. Min-max, if max f and min f are the maximum and minimum values, then the minimum f times the difference is always less than the integral itself, which is always less than the max. So essentially what this is saying is, if you have some curve, if I do a rectangle using the minimum, this can never be more than the actual integral. And the same thing, if I take if I go all the way up to the top corner, the max value, this has to be more than the actual integral. So the integral lies somewhere between the smallest and largest possible rectangles. And the last one here, you've got domination. This just says if f of x is more than g of x on some interval, then the integral of f of x is more than the integral of g of x, which makes sense. And if f of x is greater than or equal to 0, then the integral itself is greater than or equal to 0. So if the function never goes negative, the area can't be negative either. Okay, so example 1. So it gives us, suppose f of x from -1 to +1 is 5, f of x from 1 to 4 is -2, and h of x from -1 to 1 is 7. Find each of the following. So f of x from 4 to 1. So that's this one, but reversed. So I don't know 4 to 1, but I do know 1 to 4. But if I reverse the bounds, I just have to drop a negative sign out front. So, and then this is known from 1 to 4, so this is negative, and then the integral itself is -2, so the whole thing is just +2. So here from -1 to 4, well, I don't know -1 to 4. I know -1 to 1 and 1 to 4, so this is the same thing from -1 to 1 plus from 1 to 4. Well, from -1 to 1 is 5, from 1 to 4 is -2, so the whole thing is -3. So this one, we're going to break it first. Normally I wouldn't do this. -1 to 1 of 2f of x dx plus -1 to 1 of 3h of x dx. Well, I can factor those constants out, so 2 -1 to 1 of f of x plus 3 -1 to 1 for h of x. Well, this, I know that value, that's 2 times 5, it's right there. This one is 3 times 7, it's right there. So this is 10 plus 21, so the whole thing is 31. So let's see here, from 0 to 1 of f of x. This one I cannot solve. I do not know enough information. It's not just half of that. You can't do that. So just because you break the bounds in half does not mean you can cut the value in half, because you don't know what the shape of the curve actually is. Okay, from -2 to +2 of h of x, this one also not possible. I don't know anything about h from -2 to +2. I know from -1 to 1 is 7, but nothing from that. Okay, and then -1 to 4 of f of x plus h of x. Well, so this would break. This would be -1 to 4, whoops, off the screen, of f of x plus -1 to 4 of h of x. Well, this one also not possible, because I do know this, I can figure out this one. In fact, I already did. It's this one up here. It's 3, but I can't do this one. I don't know anything about h of x from -1 to 4. Okay, so here it says show that value from -1 or from 0 to 1 of root 1 plus cos x dx is less than this. So the integral is always less than the maximum value and more than the minimum value. So if I can figure out what the maximum value of this is, and if it's less than 3/2, then the integral is also less than 3/2. No, because b minus a is going to be 1. So essentially we're using this rule. It has to be less than or equal to f max times b minus a. So f max is the maximum value of this function. Well, the largest cosine can be is 1. So the largest this can be is 1, the square root of 1 plus 1. So f max is root 2. B minus a is 1 minus 0. So this is root 2 times 1. Well, root 2 is approximately 1.414. So since this number is less than 3/2, so I'll put it the other way, this integral has to be less than 1.4, which means it also has to be less than 1.5. Because if it has to be less than 1.4, there's no way it can be more than 1.5. So this is less than 3/2. So essentially you have a chain of less than signs. Okay, so down here at the bottom we got the average value. So if f is integrable on the interval a to b, the average or the mean value is, so average of the function is 1 over b minus a times the integral of the function from a to b. So example 3 says find the average value of 4 minus x squared on 0 to 3. Does f actually take on this value at some point in the given interval? So let's look at the graph of 4 minus x squared. Menu, graph, oops, wrong button. Okay. So the average value, so the average value of f is equal to 1 over b minus a from a to b of f of x dx. So let's fill in our values. So 1 over 3 minus 0 from 0 to 3, 4 minus x squared dx. Well, this is 1/3. This I'm going to use my calculator for. I'm going to use the numerical integration. So menu, so calculate, integrate 4 minus x squared from 0 to 3. Gives me a value of 3. So this integral comes out to be 3. So the average value of f is just 1. So does f actually take on this value at some point in the given interval? Well, to answer that, we just set our function equal to 1 and solve. So negative x squared is equal to negative 3. X squared is equal to 3. So it actually occurs twice at positive negative root 3. So there's 2 places the function takes its average value. Okay. This is the same thing. I don't know why I put this box twice. Oh, sorry. If f is continuous, then there's, so actually, it's proving this last point here. So there is always some point at which the function will equal its average value, which is what we just proved up here. So our average value is 1. There is at least one point at which, so there's some value for c where it equals the average. The formula looks real similar. That's just the only difference is the left-hand side here. Okay, connecting differential and integral calculus. So the derivative operation d over dx and the integral operation from a to x are opposite operations. They cancel each other out. So down here it says if capital F is any antiderivative f, then the integral of little f of t is equal to capital F of x plus c for some constant c. I'm setting x in this equation equal to a gives you this, so the c value, the constant value here at the end, is always equal to negative capital F of a, whatever that happens to be. So putting it all together, from a to x of f of t dt. Now these t's don't have to be t's, they could be y's, z's, doesn't matter. It's capital F of x minus capital F of a, where f is the antiderivative of the thing that, sorry, the antiderivative is the thing that has a derivative of f. So for example, 1/2, that's a bad example, x squared, its antiderivative is 1/3 x cubed. Because if I take the derivative of 1/3 x cubed, so if f of x is x squared, capital F of x is 1/3 x cubed, because the derivative of this is this. So technically it's a plus c at the end here that we'd have to figure out the value for. So example 4, find the integral from 0 to x sine x using the formula, blah, 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 here. Now we can't just use our calculator to do this because the calculator only works if we have two numerical bounds, number to number, so with a variable. But the rule is you take the antiderivative, plug x in, minus the antiderivative, plug the value of a in. So if our function is sine x, so that's our f of x, our capital F of x is the thing that has a derivative of sine. So the thing that has a derivative of sine is the negative cosine. So that is negative cosine x minus negative cosine of 0, because for this problem my a value is 0. So this is negative cosine x. So the cosine of 0 is 1, so this is minus minus 1 or plus 1. So the integral from 0 to x of sine x dx is equal to the negative cosine of x plus 1. If I take the derivative of this, I should get that back. And that brings us to the end of the section.